Can I rub the board?
Sir, wait.
Sir, 1 minute.
Yes, sir.
Sir, wait.
Sir,
Done.
This is a triangular plate of height h. Triangular plate of height h. I am taking this to be of breadth b. But I don't want the answer in terms of b. I want it only in terms of
H.
H.
find the moment of inertia about this axis. Find the moment of inertia about an axis passing through the base.
So can we?
Will you try? Was my question.
Yes, sir, we will try.
Yes, sir.
For uniformity in the class, shall I tell you what kind of element I will consider?
Yes, sir.
Yes, sir.
The element I consider will be this.
Okay, sir.
Let me call this A, B, C. This is B, E. At a distance of y of thickness dy.
D.
At a distance of y of thickness dy.
D.
Sir, is it a equilateral triangle or anything?
No, normal triangle. We don't know if it is isosceles or equilateral or anything. It can.
So answer only in terms of h, right?
Answer only in terms of h.
Oh, so that's a small element dy, right?
Yeah, of thickness dy.
Okay, sir.
At a distance of y from the base, you consider a thin strip.
I am getting mh square by 8.
No,
mh square by 3.
no,
2mh square by 3.
no.
So in this, can we take the y from A?
You can, but it is beating around the bush again. You can, no problem. But why do you want
So
to change? For uniformity in the class, I took this way. You will take it the reverse way. Where
So some similarities I was getting so थोड़ा complicated expression आ रहा था.
अरे नहीं, similar
H minus y.
सर वो सिमिलरिटी से यूज किया तो हाँ सर कॉम्प्लिकेट है.
चुप है, बड़ा आसान है, कुछ भी बोलते.
Sir, 1 minute.
so it's not mh square by 3, right?
No.
Okay.
Listen,
2mh 2 by 3.
di
mh square by 6 होगा.
mh square by
6.
हवा में तीर मारा सही मारा.
अरे
हाँ सर, ये फ्लूक मारा इसने.
हाँ, listen, have a look. This element that you considered, every small part of the element is at the same distance from the axis. Yes or no?
Yes, sir.
Yes, sir.
So it will be dm into y square.
Yes, sir.
Now of xi square.
हाँ,
Every small part of that strip, उस strip का हर small element is at the same distance from here.
Yes, sir.
Yes, sir.
Now how do you substitute dm? Mass per unit area, r base into height
yes sir.
into area of the strip. Area of the strip is dE length into dy. This is mass per unit area into area of the strip into y square. I get the moment of inertia of this particular element, which I will have to integrate provided I know the value of the length dE. Now something that we learned before we were born, similar triangles. We learned this before we were born.
Yes sir.
Yes.
ADE is similar to ABC.
A test property.
Yes, sir.
So this is H minus Y. H minus Y by H. Height of the smaller triangle divided by the height of the bigger triangle should be equal to the base of the smaller triangle divided by the base of the bigger triangle.
Yes.
Yes, sir.
So DE is equal to B by H into H minus Y. 2M by BH. DE is B by H into H minus Y into I square dy is DI. This dy I kept as it is, this y square I kept as it is, DE I substituted from here, and then I will use
B and B are getting cancelled.
B gets cancelled. So sweet. 2m by h square integral of hy square dy minus integral of y cube dy. Least value of y is 0. Maximum value of y is h. Now don't tell me you don't know the integration of this and this. Bring h outside, simplify, tell me the answer. M h square by 6. Please cross verify if you are getting this answer.
हाँ सर मैंने ऐसे ही सॉल्व किया था इसलिए mh square by 6.
मैं नहीं मानूंगा.
सर ये उल्लू बना रहा है.
नहीं सर बाय फ्लो.
सर
हम्म.
सर मैं स्क्वायर का हाफ वाला सेक्शन सोचा था तो वो चलेगा.
स्क्वायर का
स्क्वायर का जैसे स्क्वायर का mh स्क्वायर ma स्क्वायर बाय 6 होता है तो इसका mh स्क्वायर बाय 6 होता है.
A is the side of the square. Here, H is the height of the triangle. Dur dur tak there is no comparison.
अच्छा oh, sorry sir.
Yes, so mh square by 6 here after integration. Yes, about it.
Yes.
आ गया सर.
Now listen. For a rectangle, you did not calculate the moment of inertia about the diagonal. For a square, you did, but for rectangle, तूने नहीं किया. Yes or no?
Yes, sir.
Yes sir.
You didn't calculate about this because you couldn't apply perpendicular axis theorem. You were handicapped. I was considerate then, naturally. Now that you know, if I give you M to be the total mass, the formula will not change. Why will the formula not change here? Recollect, for one piece of a pizza, what did you tell me moment of inertia to be mr square by 2?
mr square by 2.
So total piece of the pizza will also be mr square by 2. Mass distribution is not changing. Only thing capital mr square by 2. Yes or no?
Yes, sir.
Yes sir.
I take one half of this rectangle, I get a particular formula called mh square by 6. Another half I take, it should become capital mh square by 6. Yes or no?
Yes, sir.
Yes, sir.
The same logic you are applying. Right? But the problem is, h is this value. H is the height of the triangle. And I want the answer for the rectangle in terms of L and B. You're getting my point? H is the height of the triangle. It is not that height of the triangle is not along the diagonal. Height of the triangle is not along the diagonal. I hope it makes sense to you.
Yes sir.
H is not half the length of the diagonal. You substitute H as half the length of the diagonal, you are in soup. Now, calculate H in terms of L and B and substitute here. You will get the moment of inertia of the rectangular plate about the diagonal. I know the moment of inertia of this triangle about this. Formula will be the same for the complete rectangle. Only difference, total mass will be taken. 100% is everybody convinced. The same logic
Yes,
I
sir.
explained,
Yes, sir.
Yes, sir.
Yes, sir.
right? Now,
Sir,
how
let
do
us
I
find
get
that,
this
sir.
H?
Sir,
Equate
thoda
the
to
areas. L into B is the area of the rectangle, which will be 2 times half into base into height. Height into what will this base
L square
length
plus B
be?
square under.
L square plus
L
B.
square plus B square. This is area of this triangle. 2 times that should be length into breadth.
Yes.
Yes.
2 will go. LB is equal to H into root over of L square plus B square. What are you calculating? Value of H. H will be LB divided by root over of L square plus B square. So my moment of inertia about this will be capital M by 6 LB H square L square B square by L square plus B square. This will be the moment of inertia of the rectangle about its diagonal. How do I cross verify that I got the correct answer? If I put length is equal to breadth, it becomes a square.
Square, yes, sir.
Square.
Square का diagonal का length मुझे पता है.
Yes.
Moment of inertia about the diagonal of a square is how much?
MA square by 12.
MA square by
M square by 2. For a square, right here, for a square, L is equal to B is equal to A. L is equal to B equal to A. M by 6 into 8 to the power 4 by 2 A square.
yes, sir. MA square by 12.
स्क्वायर का यही तो बोले थे आपने. स्क्वायर का तो बड़ा आसानी से परपेंडिकुलर एक्सिस थ्योरम में अप्लाई कर लिया. यहाँ तो परपेंडिकुलर एक्सिस अप्लाई नहीं कर पाओ. You used the reverse logic of this. From the disk, you calculated the one piece of a pizza. Now here from the triangle, I am calculating the complete rectangle. Reverse, you should be able to do. Is
Yes,
the
sir.
logic clear to all?
Yes, sir.
Last one.
Done, sir.
Sir, 2 minutes. Yes, sir.
I'll just be back in a second. Can I rub the board?
Yes, sir.
Yes, sir.
This is a square plate of edge length A. M is the mass of the plate. M is the mass of the plate. Find out the moment of inertia about an axis which makes 15 degrees with the side of this square. Find the moment of inertia about this axis. Will you try or should I discuss?
Wait.
I am waiting.
Sir, can you repeat the question?
Square plate, moment of inertia about this axis, making an angle of 15 degrees with this axis.
So can you show visualization of how it will rotate? If you have like a
This is the axis.
yes, sir. Okay, sir, understood.
So is it MS square by 16?
I think no. Though I don't remember the answer, you'll have to wait.
Okay, sir.
If this is the center of mass,
R.
do I know the moment of inertia about this axis?
Yes, sir. MA square by
M square by 12 because x and y axis for a square, however I rotate,
it
it
will be
is
the
passing
same.
They are
through the center
perpendicular.
of mass. M square by 12. I further rotate, it will be along the diagonal. For a
Yes,
square, this is M square by 12. Turn, I have no problem with that. It will remain M square by 12. Yes or no?
sir.
My problem is in the calculation of this value called D.
6.
So I will be MA square by 12 plus M into D square.
Yes,
If somebody can tell me the value of D, my job is done. How will I tell you the value of D? Watch out for this. This complete angle is 90 degrees because this is perpendicular. D is the perpendicular line between the two parallel axes.
Yes, sir.
So this angle is 90 and this angle is 45. Who told you this angle is 45?
30.
Sir, that's the diagonal.
Yes.
That's the diagonal of the square.
Yes, sir.
So 90 minus 60 will be how much?
30.
30.
And I know the length of the diagonal. Total diagonal length will be a root 2. Half of that will be a by root 2. D will be equal to a by root 2 cos 30. Substitute this D here, you get the answer.
मैंने MA square by 12 को ऐड करना.
I is equal to IC plus M into D.
D square.
One second, I'll be back. Don't make Can I rub the board?
So
Yes, sir.
explain why you took inertia as ma square by 12 along that axis.
X-axis. Square plate का x-axis moment of inertia कितना है?
Ma square by 12.
So x-axis
Actually,
can be this way, however it is, I can have x-axis.
yes, sir, got it. Yeah.
Listen to one very tricky problem given by Irdo. He says this is a complete sphere of radius capital R, complete solid sphere.
Yes,
Say
sir.
something.
Yes, sir.
Yes.
Yes,
Yes.
sir.
Yes, sir.
From a solid sphere of radius capital R, if I cut out another solid sphere of radius small r, capital R is small r plus delta r. Delta r is small. If I cut out a solid sphere of radius small r, don't you think I should get the moment of inertia of a hollow sphere?
You should, sir.
Yes, sir.
Yes. Yes.
Prove it. From a solid sphere of radius capital R, you are cutting out another solid sphere of radius small r, such that delta r is very, very small. It should be thin only than a hollow sphere. Delta r limit, delta r tends to 0. Only then it will be a hollow sphere, right?
Yes, sir.
So, question is, from a solid sphere of radius capital R, remove a concentric solid sphere of radius small r. Your final moment of inertia should be 2 by 3 mr square. M should be the mass of the shell. Agreed?
Yes, sir.
कुछ गड़बड़ लग रही है.
गड़बड़ कुछ भी नहीं.
सर लेकिन आपने
Problem-
DC क्यों बोला सर?
ट्रैप प्ले कर रहे हैं।
ट्रैप नहीं है, डायरेक्ट इरिडो प्रॉब्लम. हाँ, प्रॉब्लम इज स्लाइटली इंट्रिकेट मैथमेटिकली, बट इट्स a CDC problem. No trap. See the problem, genuine problem. From a solid sphere of radius capital R and another solid sphere of radius small r, concentric is removed. We should get the moment of inertia of a hollow sphere. अगर आप ट्राई नहीं कर रहे हो बता दो, मैं सॉल्व कर.
सर
नहीं,
कर
नहीं
रहे हैं
कर
सर,
रहे हैं,
ट्राई कर रहे हैं सर. सर मुझे ऐसा
Listen,
So here do we have to use that binomial approximation?
Yes, obviously.
Sir, I'm getting everything. But in the end, I'm getting 1 minus dr upon r to the power 5. Like that's one of the parts. Sir, I don't know how to eliminate this
Okay,
dr.
listen, the key catch is understanding that the density is the same.
Yes, sir.
How will I write the moment of inertia of the outer sphere? 2 by 5 density into 4 by 3 pi r cube. Will this be the mass of the outer sphere?
Yes, sir.
This into r square. Is this the moment of inertia of the outer sphere? Solid sphere का 2 by 5 mr square.
Yes, sir. Yes, sir.
Yes, sir.
Minus inner solid sphere का 2 by 5 rho into 4 by 3 pi r cube into r. Inner sphere का mass, inner sphere का radius. Agreed?
Yes, sir.
So far, so good.
Sir.
Yes, sir.
2 by 5 rho 4 by 3 pi r to the power 5 minus r to the power 5. 2 by 5 is common, rho is common, 4 by 3 pi is common. 2 by 5 rho 4 by 3 pi r plus delta r to the power 5 minus r to the power 5. Is this part of the board visible? 2 by 5 rho 4 by 3 pi r to the power 5 r square delta r. Is this r square?
So aren't you supposed to take r common first from that bracket?
Binomial expansion of this, tell me, r to the power 5.
Yes, sir.
Yes,
R
sir.
to the power 4 delta r. Higher powers of delta r and neglect.
Fire.
Higher powers, did I write this expression correctly?
Yes,
Yes,
sir.
sir.
Yes, sir.
Higher powers of delta r, why are you neglecting?
Already they are very
very small.
Tends to
These both will get cancelled out. What am I left with? I is 2 by 5 rho 4 by 3 pi 5 r to the power 4 delta. 5 and 5 will go. Right? 2 by 3 4 pi r square into delta r into rho 2 by 3 rho into r square. What have I done? R to the power 4 में एक r square अंदर रखा है, एक r square बाहर. Rho as it is रखा. 5 got cancelled. 2 by 3. 4 pi r square into delta r. Will it be dm?
Yes, sir.
Yes, sir.
2 by 3 dm into r square. Dm is the mass of the
All
shell. And isn't it the answer that we are expecting?
Yes, sir.
Yes,
Yes, sir.
Smart, right?
yes, sir. It was
Yes, sir.
Hence he zero.
सर हमने ऐसे सिमिलर हीट एंड थर्मोडायनेमिक्स में किया था बाइनोमियल अप्रोक्सीमेशन का.
ये तो फिजिक्स में बहुत बार है. ये this approach of the problem physics में you encounter 10 number.
So can you explain the second last step again?
Which is the second last step? This
So
or
on the left hand side, yes, sir, that one.
left hand simplification. यार. Why explain this?
No,
2
sir.
and
Like,
3 I kept outside. Density I kept outside. 4 pi r squared 1 r squared delta. Just rearranged the variables. So that 4 pi r squared delta r is kept in one
dm
bracket,
is
right?
4
That
pi r
gives me
square
the
into
volume of the shell. 4 pi small r squared into delta r gives me the volume of the shell. Surface area into thickness.
Yes, sir.
Below.
So the binomial approximation should be r plus 5 into delta r, right?
Yeah.
because in binomial expansion we bring the power uh, as the coefficient of delta r.
अरे वो उल्टा लिखा है, चलता है bro से.
You want to bring R first outside and write it as delta R by R.
No,
Correct,
sir, in
But
physics,
I don't need it. A plus B to the power n. R to the power 5 plus 5 R to the power 4 delta R. Delta R square से neglect कर दिया हमने. R to the power 5 got cancelled.
okay.
एक सेकंड रुको यार आ रहा.
One.
Wait.
Yes, sir. Done.
So we're in doubts now.
No. Listen, last problem of the day. But before that, homework. First 20 exercise problems of exercise 1, rotational dynamics. Rotational dynamics 1 to 20. Or on moment of inertia. Rotational dynamics, exercise 1, 1 to 20. Think carefully and solve this problem. This is a solid cylinder of radius r, length L. M is the mass of the solid cylinder. Mass of solid cylinder. M is the mass. L is the length. R is the radius of the solid cylinder. Right? You want the moment of inertia about this axis. Technically, you are asking me the moment of inertia about this axis. Solid cylinder. Will you try or should I discuss?
Sir, we will try.
I am waiting.
Sir, I'm sorry I got disconnected. So what is this cylinder thing?
Solid cylinder. Solid cylinder, mass M, length L, radius R. You want the moment of inertia about this side. About this axis. Axis passing through the center. Perpendicular to the length.
So will you be discussing that exercise 3 of COM or are you just sharing the recording of lecture?
No, I'll discuss it in your class.
Okay.
May not be today's lecture, but next class I'll discuss it in your class.
So if possible,
You
can you
can-
also send their recording? So because वो तो हो जाना चाहिए, I guess.
हाँ सर.
It should overlap.
Okay, I'll send it.
सर
Okay.
और कोई डाउट्स रहेगा तो वो क्लास में डिस्कस कर लेगा वो टाइम.
Okay.
So over here, should our element be a disk?
Yeah. The disk that you consider will be here of thickness
Dx
dx
at a distance
at
of
a
x.
distance of x.
Yes, sir, I did that only.
But whole of the catch lies in how will you calculate the moment of inertia of the disk about this axis before
So parallel,
Yes.
parallel
Parallel
axis
theorem.
theorem.
Because
Sir, why?
integration is summation. Summation or subtraction of moment of inertia are done when they are about the same
Axis.
Axis.
सर वही
if you consider the element to be a disk like this,
Sir, give us 1 more minute now. 1 or 2
just
minutes.
that last integration.
Yes, sir, we are doing that only.
okay, okay.
सर खुशी आ रहा है सर, आज के क्लास में एक सम तो आ गया.
वही सर, अभी ये वाला ही आ रहा है.
So what's the final answer?
ml square by 12 plus mr square by 4.
हाँ सर, वही आया. ml square by 12 by plus mr square by 4. तो मेरे को लगा गलत है क्योंकि वो mr square by 4 है, इसीलिए मैं सोच रहा
सर
था.
मुझे mr स्क्वायर बाय 18 प्लस कुछ आ रहा
मेरे को वही आंसर.
Suno, the element that you consider is a disk.
Yes sir.
और इस डिस्क का मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस कैलकुलेट करके इंटीग्रेट कर. ऑल मोमेंट ऑफ इनर्शिया शुड बी अबाउट द सेम एक्सिस, तभी इंटीग्रेट कर पाओगे.
Yes, sir.
तो डिस्क का मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस कितना है?
Square by 4.
mr square by 4.
है. यस
Yes, sir. Yes.
That I can translate about this. This is IC passing through the center of mass.
Yes sir.
Is
यस
IC passing through the center of mass? Yes or no?
mr square by.
So technically, di about this di is dm r square by 4 plus dm into x. Parallel access theorem. dm is the mass of this element. This is IC passing through the center of mass. dm into d square.
Yes.
यस
Mass per unit length into length of the element r square by 4 plus mass per unit length into length of the element x square. क्या बोल रहे हो यार? सॉलिड सिलेंडर है, मास पर यूनिट वॉल्यूम ले लो ना यार, लेंथ थोड़ी लोगे, ले लो. डिनोमिनेटर भी एरिया से मल्टीप्लाई कर दो, न्यूमरेटर भी एरिया से मल्टीप्लाई कर दो.
Yes.
हाँ सर
Okay,
तो हो
cancel
जाएगा.
करो.
यस सर.
So integral di is mr square by 4l integral dx minus l by 2 to l by 2 m by l integral x square dx minus l by 2 to l by 2. Least value of x is minus l by 2 to plus l by 2.
सर मैंने दो इतने डम मिस्टेक किए. एक तो पहले मैंने वो आई रोट दैट एज mr square by 2 and then second mistake I made was I took the limits as minus l to plus l.
सर वो
Minus
इसे
Sir.
l to plus l. Okay.
सर मैंने ऐसे ही किया, बट मैंने सर मेरे को पहले ही सोच लिया था कि इसका फर्स्ट वाले का टर्म का तो वही होगा. प्लस सर क्या कहते हैं, मैंने एक वो आपने जैसे उसका शॉर्टकट ले लिया ना dx by l, तो उसका पूरा लॉन्ग किया तो टाइम लगा उसमें. लेकिन सही आंसर यही आंसर है मेरा.
mr square by 4 plus ml square by 12. आंसर देख के कुछ बच्चे पूछते perpendicular axis theorem apply करना है क्या? Perpendicular axis theorem is applicable only for a plane
having
Lamina.
सर वो बाय फ्लूक आंसर आता
perpendicular axis पर
यस सर
perpendicular apply कैसे करोगे? कौन सा लामिना लेकर apply? It appears coincidental that the answer is the same, but in the first step itself you have blocked.
यस
Sir, I have a doubt in a question. Can I ask?
बोलो.
Sir, in the question where the axis of rotation was inclined at 15 degrees from one of the vertices of a square, you said that we rotated the coordinate system and then applied parallel axis theorem, right?
This is IC.
Yes, sir. Sir, can we do it for a rectangle as well? Like the same method?
I take this, I have no problem. If you know the moment of inertia for this, I have no problem.
But I don't know the moment of.
Right. The problem is I don't know the moment of inertia for this. Even now, after calculating, I know about the diagonal. Triangle ka calculate kiya, so I know it about the
Diagonal.
diagonal. Wish you all a happy weekend.
Thank you, sir.
सर एक
सर हैप्पी संडे सर,
Same to you,
वीकेंड का
sir.
एक दिन तो चलेगा.
एक रिक्वेस्ट है सर, फिजिक्स गैलेक्सी एक बुक है सर, उसमें बहुत सारे रिड्यूस मास के प्रॉब्लम्स है सर, तो आप वो हेल्प कर सकते हैं? उसमें बहुत टफ सम है, वो रिड्यूस मास से हो ही नहीं रहे.
Reduced
अरे
mass
वेरिएबल
का
मास, वेरिएबल मास, सॉरी सर,
variable mass ka complete what we have done only. You don't need much of that. Arsak variable mass ka questions itself didn't come in JEE. We ourselves stretched it beyond the limit.
आज तक नहीं आया सर.
It's not come.
नहीं.
Variable
God,
mass
sir.
ka एक ही question 80s में they gave on DP, which is given in your booklet and which we dealt with in the class.
यस
Thank God,
Yes,
sir.
sir. वो dust
Thank you
particle.
sir,
मैं
sir.
बहुत
बहुत
tough-
relief
Thank you,
दे
sir,
दिया
so
sir.
much. इतना
Don't jump too much on variable mass. It's unnecessarily deviating. But yet if you want in one of the doubt lectures, I can discuss few of those doubts. Not an issue.
Thank you
Thank you,
sir. Bye
sir.
sir.
Thank you, sir, so much.
बाय सर.
Thank you, sir. Bye, sir.
Enjoy your
Thank you,
weekend.
sir. Bye, sir.